Hi everyone, my name is Anton Bukov. I'm co-founder of 1inch, and I'm here to show the newest DeFi primitive called token hooks. What is token hooks? It's actually dynamically expanding and changing functionality of any token. There are many things tokenized on chain, including some projects like DAOs, also some like DEXs, AMMs, like lending protocols. All those pools, they have proper tokenizations, and holders of those tokens, they could, if these tokens and tokenizations would be hook enabled, this would let holders of those tokens to change behavior of their balances dynamically. So this means that if your token or any tokenization thing is hook enabled, this means that owners of this token can add own hooks. They could add some hooks approved by DAO, or they could add permissionlessly any hooks. This is something you could decide on your own when you use this kind of library. But basically, if it's like permissionless environment, users can add any hooks they wish to change functionality of their token. Whenever their balances will be changing, hooks will be notified about this, and they can handle it in like any manner. So basically, your token have to be hook enabled. It's an extension of ERC20 called ERC20 hooks. Or if you already have something tokenized which is not hook enabled, you can build a wrapper. Just use ERC20 wrapper from standard OpenZeppelin library and make it hook enabled. So then you can have arbitrary hooks deployed for your token, like any. I will show a few examples, but I hope to see much more different examples of different hooks. And yeah, in this example, holders can permissionlessly add any hooks they wish. But yeah, if you're building this system, you can change this. You can make only approved hooks or anything you want. So what's actually hooks adding to the token behavior? So how far you can change your behavior? So actually, those hooks, they can be developed permissionlessly. So this means that even if I'm building some system which is tokenized and these tokens are hook enabled, I can make it open in terms of anyone can develop any idea of hook they wish, and owners of these tokens will be able to have this functionality. Also, hooks, they are risk-free. So it's actually like balance hooks. They're like hooks on token balances, and they can't prevent transfers, mints, burns, whatever is usually happening to your token. Hooks are only getting notified, but they can't prevent this from happening. And yeah, users are free to participate in multiple hooks, but amount of hooks, number of hooks should be limited. You could not have infinite amount of hooks for some systems. If your system is, for example, lending protocol, you should make sure your users are still liquidatable. They should have limited number of hooks and limited gas spendings in those hooks. So yeah, there are two examples we built. So originally we were trying to build all those two things separately, but then we came up to this concept of hooks and realized that both of concept can be implemented as hooks. And moreover, if we would have it as hooks, we can add any arbitrary logic later as a custom hook. So farming incentives hooks, it's very similar to farming pool, which was implemented in 2020. With my teammate, were the guys who implemented the first farming pool for synthetics in 2020. And now we're like reimagining this idea with hooks, because this would let users to have multi-farming permissionless, and it's also risk-free. Any pool where you lock your LP tokens or anything else, are not risk-free. You have to audit those systems to make sure those pools will not steal your money or your tokens, or they will not be locked forever, or any other issue would not happen to you. When you are using hooks, you can use any hooks without any audits, and it's still safe. In the worst case, hook will just add a lot of gas when you will try shut it down from your balance, to detach it from your balance. But yeah, it's not affecting your balance in any way. They can steal or block your funds. And delegation hook also, we call it delegating. So it's actually, yeah, you can have some balance there, and you can delegate your balance to someone. And this hook itself is also ERC20, which is read-only, and which is representing total delegated balance of entities. It's one of the cool features for on-chain governance. We, for example, have delegation for votes in governance, and we also have delegation for unicorn power for resolvers. So you could have multiple delegation destinations. This approach is much more agile than any other ERC20 extension like ERC20 votes or any other similar, because you have to inherit those extensions before deployment. You have to inherit it when you write the code of your token, while hooks can be added much later at any stage. So it's dynamically extending any token functionality per user. So some users can install some hooks. So you are not enforcing this behavior for everyone. And what is hook itself? Hook itself is just a smart contract with one single method, update balances. It's getting notified about balance changes in a very similar way how internal update method of OpenZeppelin ERC20 implementation looks like. So yeah, it's very similar. We just added base hook implementation to make sure you will not forget any important checks, like who is the caller. The caller of this method should be always the token this hook is attached to. So we just inherit from base implementation, which perform these basic checks. So it's just a little bit of comfort here. So yeah, that's basically the whole presentation. I can spend more time on this slide probably, re-explaining the concept. So in the past, whenever you want to incentivize someone to participate in your protocol, you have to deploy some farming pools, and users have to trust those pools that those pools will not steal or block their funds or whatever else bad could happen. With this new approach, you could make any tokenized thing of your protocol, if it's like LP token or debt token or collateral token or like whatever you're building, or it could be a DAO token or it could be a staked DAO token. We also use this system for staked 1-inch, which we call unicorn power token. So it's non-transferable, but it still works with all those primitives because of the proper tokenization, where balances are not changing on the fly. Yeah. So this thing is only compatible with tokens which balances are not changing with time via formula, depending on time. So all balance changes should happen transaction-wise. So yeah, just imagine if Balancer, for example, would just inherit this functionality, ERC20 hooks for their pools. This would let DAOs to co-incentivize those pools. Just imagine 3-4 different DAOs could set up hooks with incentives for some for the same pool, for example, and this means that participants of this pool can just plug into those hooks, like 3-4 hooks, and get incentives from all of them, and it's completely risk-free for them. Development of those hooks is permissionless, which is also cool. Yeah, and you could have like a permissionless, risk-free multi-farming. This sounds like a economical craziness. So yeah, we built only 2 of them. We unified our approach to build it in unified way. So originally it was 2 different things which were not owning tokens. It was farming and delegating, and we found a way to unify this concept via token hooks. And I personally hope to see much more different hooks implementations. Maybe we will see them on hackathon or somewhere else in production. It's also very cool to build systems out of these hooks for any kind of governance systems. So for example, we could have a snapshot hook, which will make snapshots of ERC20 balances. For those users who won't participate in this, they will install this hook, and whenever, for example, administrator or operator of this hook would decide that it's required to make snapshot, they will make transaction, and this hook will remember all the balances before this event. And it could represent it via external ERC20 read-only smart contract, so your governance system could later work with this read-only ERC20 implementation or something like this. In general, this system is much more agile than any ERC20 extension, because you can change how things works after your token is being deployed. So that's actually it. Thank you. Any questions? Yeah, for now, so the question was who is paying for those instructions for being executed. So yeah, who is changing the balances is actually paying for hooks notification. For example, if you have some hooks A and B and I have some hooks B and C, if we're changing our balances, for example, you transfer some tokens to me or I'm transferring some tokens to you, we will notify hooks. For example, we will notify hook A that your balance was decreased, but this hook will not see my balance, for example, or my address, because I'm out of this hook. I'm only participating in B and C. I'm not participating in hook A. So yeah, whoever will change balances will pay for this. But number of plugins connected to one address and amount of gas which they could spend should be limited. And this should be defined on deployment stage. Whenever you inherit from these ERC20 hooks, you have to pass arguments, how many hooks should be allowed per address and what's their gas limit. So using this system, you could, for example, have incentives on debt tokens. If you're building like a lending protocol and your debts are properly tokenized, their balances are not changing on the fly, for example, this could be achieved with a compound-like approach where balances are not changing, price is changing of asset to underlying asset. So yeah, you could have incentives for debts, because obviously you can't put your debt into the pool without collateral. It should not work as it was implemented in the past implementations of farmings. But this one would work for you. If you have anything which is tokenized properly, you could use hooks with this. More questions?
Yeah, I actually have 2 questions for you. The first one is, what happens if a hooks revert? Will that prevent the transfer from happening? And the second one is, are you worried about the possibly reentrancy risks if the hooks is used in the case of, like, say, 4626 or something like that?
Yeah, a great question, actually. Yeah, originally, when we came up to this idea, we discovered that those who execute transaction or execute this call can lower gas limit to make those hooks fail due to low gas, for example. And yeah, we wanted those hooks to be as less invasive as possible. That's why originally we implemented it like, we check that we are passing 200,000 of gas into hook and make sure if it will fail, it's not due to low gas, so it's fine. It's fine for token to transfer while hook is failing. I mean, hooks can fail if their logic is written in with some bugs or something, or if it's intentional, it will spend your gas, but it will not prevent your token logic, because this could be mint of token shares, burn of token shares, transfer or liquidation, or like whatever is your protocol about. And hooks should be non-invasive. Now it's using optimistic approach, but still safe. We're notifying hook, and if it's not failing, that's okay. If it is failing, we're checking that we passed at least 200,000 gas inside to make sure it was not failing due to low gas. And yeah, it's like optimistic, but yeah, it's protected. And in terms of attacks, the thing is that it's notifying after balance changes, as it should be. So yeah, if your contracts and protocols are following CEI notations, checks, effects, interactions, you should not have any problems here, because yeah, it's also built the same way. It's also checks and effects, and then do any interactions separately. So yeah, that's actually the great way to avoid reentrancy attacks. Not to put reentrancy guards everywhere on every method of your protocol. You can just write every method using these checks, effects, interactions notations. So perform checks and state changes, and then only after that perform external calls like transfer froms to any tokens, or like whatever external calls you are willing to perform. If you will have code written like that for all your protocol or many protocols, even if someone will be able to perform reentrancy attack, it will not actually attack you at all. It will work in a strange way, but it will be safe for your protocol. So yeah, follow checks, effects, interactions pattern, please. More questions?
How do you see this interacting with my own token position in the contract? Like, for example, let's say that I want to reset the allowance to 0 after a transaction has happened. For example, I've given an allowance to a DEX to spend up to my max slippage, but the actual allowance consumed is obviously slightly less than that. And I just want to give it a one-pass allowance. So I want the hook to affect my position again. How do you see that happening?
Hooks are actually balance hooks, so they're not anyhow interacting with your allowances. So whenever your balance is changing, it's notifying hooks associated with the accounts participating in this change. So there are like 3 ways to change balances in ERC20 implementation from OpenZeppelin, for example. That's like the most popular one. You can transfer balance, you could mint balance, or burn balance. So whatever you are touching, it will notify those balance hooks. And yeah, regarding approvals, yeah, it's not approval hooks at all.
But during a transfer from an approval is consumed, right? Because somebody else is spending on my behalf.
Yeah. If you have some hooks connected to your balance, if someone is changing your balance on your behalf, yeah, it doesn't matter. They would execute and they would also pay for gas. For example, if you would have some farming incentives in some lending protocol for your collateral, for your debts, someone who would liquidate you, they would pay all the gas for all those hooks execution. That's true. More questions?
Do you have any other governance ideas, use cases for these hooks?
Yeah, I said about snapshots hook. I think it makes sense to build it because, yeah, I found some useful implementations for sure in ERC20 extensions of OpenZeppelin and some other libraries. But for me, it seems that, yeah, it's too strict. If you need to include this logic on compilation time, when you write your code for your protocol, it's one thing. But if it's something what you could add later, like 1 year later, you want to have incentives or you want to have governance to voting or like whatever other functionality you can wish. So yeah, hooks help with that actually. More questions? So it should be obvious, yeah?
Not really a question, more a comment. You should write an ERC that specifies everything you just did and mentioned.
Yeah, I agree. I agree. We should push this as ERC standard, and we should probably try to push it to Open Zeppelin library as a separate extension with hooks as a separate folder, because they have folder for extensions. We could put ERC20 hooks there. They actually audited this thing, so yeah. I agree. Thank you.